Clara and 3 friends were born on March 11th. Leslie is 5 years younger than Clara, Mike 2 years younger than Clara, and Thomas is 3 years older than Clara. Now, instead of just going to Clara and say, hey, Clara, how old are you? Right? That would probably be the logical thing in life to do if you wanted to know how old Clara was. But for some reason, you have this ability to know that the product of their ages is 61,136 more than the sum of their ages. You don't know how old they are, but you know this. So this is an example of a bad real life problem, because this would never happen in real life. But despite that, the question does give us an opportunity to practice some math skills that are important, even though the example itself is ridiculous. It's like, yeah, I don't know how old you are, but I happen to know that if I multiplied your ages together and added them together, there would be a difference of 61,136. Because that's common knowledge that's out there all the time. No. Okay, so what does this question do for us, though, is it practices writing an equation all with one variable. Choosing a variable for something. We want to find out how old Clara is, so we don't know, so we say, well, let's say she's X years old. Then from that, we know that Leslie is 5 years younger, so she will be X minus 5. Mike, 2 years younger, will be X minus 2, and Thomas, 3 years older, will be X plus 3. Perfect. Next, we've got some information that should allow us to make an equation. The product of their ages is 61,136 greater than the sum of their ages. So I'm actually going to start off, I'm going to make an equation. On this side, I'm going to put product. I'm going to start off with words. On this side, I'm going to put sum. I know that the product is bigger because it's greater than the sum. So in order to make these equal, does it make sense that I would have to add the 61,136 to the smaller side in order to make them equal? And if we started off with words like this, then going to the algebra is easier. If you try to start with the algebra right away, sometimes you can get lost in the details and get confused before you finished your equation. Now that I have an idea what my equation needs to look like, well, what does the product look like? Well, the product would be x times x minus 5 times x minus 2 times x plus 3. All of them multiplied together. What does the sum look like? Well, if you add them all up, you will have 4 x's. Add up my numbers, minus 4. That's my sum. And I still have the plus 61,136. And at this point, it goes to a technology part. We're going to either use a graphing calculator or Desmos to solve this. Either one, what we're going to do is we're going to put one side of the equation into y1 in your graphing calculator, the other into y2. In Desmos, you're just going to write 2 different equations for y. So once again, I'm going to go to Desmos. I'm going to shut it down so we pretend like we started it new. So our window will be the basic starting window. So I'm going to start with y equals, the left side was x times x minus 5 times x minus 2, x plus 3. And the second equation, y equals, and if I combine my like terms, 61,132. Now in Desmos, I see part of my red graph. I do not see my blue graph at all. So sometimes what students do is they start like, where is it? And they move around. which you can do that, but you might be moving for a long time. Having a little bit of knowledge about these equations can help you. So, first of all, in the blue equation, I hope you see that it's a line, y equals mx plus b. And the b value is your y-intercept. Your y-intercept is 61,132. So if you're just doing this, all right, I'm at 28. How long is it going to take me to get to 61,132? A long time. Chances of a student giving up before they get there is great. So instead, because I have that little bit of knowledge, I'm going to go to my tool, and I'm going to go to the y maximum, and I'm going to say, well, I need to go to 61,132. Maybe I go to 70,000. Perfect. And now I've got the blue line, but I'm not seeing enough of my red graph, so I'm going to change. There, I changed it to 50. Now my two graphs are showing, and the solution, when you have two equations, the solution will be where those two graphs intersect. To find that on Desmos, you just need to highlight one of your graphs, and the dot will automatically appear. Click on it. The x value is 17. The other value doesn't matter because you are trying to solve for x. So we can just go to our equation and say x is 17. What does that mean? What did the question say? How old was Claire and each of her friends now that we figured out x? Claire is 17, Leslie is 12, Mike is 15, and Thomas is 20. And it sure would have been a lot easier if we would have just asked her how old she was. And if she wouldn't tell us, we might probably do it. We could probably get it out of Mike, right? Offer him a donut, he'll tell you how old he is. No problem. Donut's expensive. Could have probably got the age out of Leslie for a Timbit. There we go. So, questions for practice on this one are 7 and 8.